Okay, so if you go to Module 3, and I'll give you this link here, it really does help get the notes. Using the notes or writing them down. If you write them down, if you need some extra time, if you're not putting in your 5 hours, if you take those notes here and then you write them down, you can count it as offline tracker time. So whatever, if you make flashcards out of it, you can count that as offline tracker time. I'm very happy to give that. So let's do this. You take a look at those notes there and see which one of these questions. All right, so in this particular question, so this is worksheet. Okay, so I'm going to do is I'm going to give you this as well. Okay, so we're on the same page. Yours might be in a little different order, so I'll slow down a little bit because it might not be the same. Might not be in the same order. Your question one might be a different question one. Tell me when you're ready. Okay. So a wave is a disturbance that transmits both matter and energy from one location to another, right? Looking at those notes, what do you think? Is that true or a false statement? Okay, so it's partially true. It does do energy, but if we see a wave, a water wave, if we put a ball in there, it just bounces up and down. It won't send it. The wave goes this way, it won't get it to shore. What usually happens is misleading is the wind will push it to shore, but the wave itself won't. So this is a false statement. It's a tricky one because what we see in real life, it's like, well, the wind makes the waves, but the energy of the wave is different than the wind blowing it. So, all right, number 2. All right, so of these, if you look at your notes, again, you'll have a part here. So what do you think letter A is, this top point? Is it a crest, a wavelength, an amplitude, or a trough? You're right, it's a crest. Letter B, so we already used crest. Is it a wavelength, amplitude, or trough? Okay, that's letter C. Letter B is this part that measures the line between A and B, and that is the amplitude. That's how high the wave is. We measure that. That's what that's supposed to. It's a little misleading in there. So letter C, you have trough or wavelength. Yep, that is right. And then that makes the wavelength letter D. All right. And you got all those? I can move on just whenever you're ready. Got a squeaky floor upstairs, so people walking around. Not only cold down in the basement, it is noisier. All right, so next one. All right, so blank waves need a medium to move through. Is that mechanical or electromagnetic? So mechanical are like sound waves and water waves. Electromagnetic is light. All right, that's the next one. So this is mechanical wave. So mechanical wave means that it needs air or water or the ground for it to move through. And electromagnetic waves are light waves that can travel between the sun and us without anything in the empty space. Now they used to think there was an empty space between it, but that's what it is. So mechanical needs so you've heard that expression, if you can't yell in space, and that's true. You can't, because there is no air particles. Let's do number 4. What is a sound wave produced by? Okay, so if you think about a guitar, which one of those things? A guitar will produce sound waves, or a xylophone. So what one of those would you think it was? So like A is light, B is vibrating object, C is magnetism, D is electromagnetic radiation. So A, B, C, or D? Yeah, a vibrating object. Question number 5. So the units for intensity of sound. So that one is directly on. Okay, so if we go here, units for intensity of sound. All right, so if we go here, we have to go toward the end. Sound, speed, where are you? I know it's in here. So, okay, so intensity. So intensity and loudness are right there on that page. So units for intensity of sound are, it says joules, newtons, or watts per square meter. Oh, nope, it's watts per square meter, I think. So intensity is watts per square meter over here. And then loudness is in dB, which measures decibels. So in decibels, you can see that where you can just start hearing normal conversations a million times bigger than the lowest thing you can hear. So this is going to be in decibels. I try to tell my kids when the grandkids are talking, I said, "Hey, decibels, kids." I'm trying to teach them science vocabulary. Oh, I went a little fast. Did you get that one? Did you need to see that again? I went too fast. I hit submit. Okay, cool. All right, so let's do the next one here. Let's go on to week 13-2. All right, so let's do this one. Okay. All right, so if we go back to this, so this one has light. So here is your radio waves are the biggest waves, then microwaves and infrared, UV X-rays and gamma rays. So it goes from radio being the biggest and gamma rays being the smallest. So 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 you're looking for radio being the first and gamma being the last. So that's A, B, C, or D. I don't know if let me make this bigger. So A is gamma and radio. B is visible in radio, C is radio invisible, and D is radio and gamma. Which one do you think it is, A, B, C, or D? Yep, you're right. Radio is, and we saw that, the radio waves were the biggest and the gamma rays were the smallest. Okay. Okay, as the frequency of light increases, the energy, okay, so frequency just talks about how many waves travel in a second. So here is one wave in a graph in 1 second. And here is 2 waves in 1 second. So they're saying as the frequency increases, so if we get these smaller and smaller, so like this one would be, so this is 4 waves a second. So the energy in this, so, and then we want to take a look at how big the wavelength is. So as I increase the wavelength, as I increase the frequency, you can see the distance between waves is smaller. All right, so the energy is going to increase in this particular case. And what did we just say? The wavelength will increase or decrease on this one. You can put I for increase or D for decrease. I'm not very good typing. That's why I always say that. It just takes me, I spell it wrong, and then takes forever. Yeah, it decreases. So as the frequency of light increases, so like gamma rays are much, they're much smaller, and they are very high in intensity. All right, so polarizing lights, if you've ever had a polarizing sunglasses, okay, and in this particular part here, it shows you that a polarizing filter, so light goes in all directions, but if you have a filter, it only lets this one part right here come through. Only lets that, doesn't let any of the others. So polarizing effect alters the light waves and only lets one wave through that's the same direction. So let's see what this says. A polarizing filter like sunglasses only permits light waves that are in the same direction as the polarizer. True or false? Yeah. Yep. And light acts both as a wave or a particle. Let's take a look at that particular one. It says the dual nature of light. Light acts as both a wave and a particle. So we're going to say what for that one? Yep. Oh, nope, that's a true one. Because it says, yep, this one says light acts as both a wave and a particle. It's crazy. It's that's what they believe is happening, but that's they know that light acts as a wave, and then there's another person that said it acted as a particle, and now we know it works for both. But it's crazy it does it. Crazy. All right, so what is produced from photoelectric effect when light hits a metallic surface? All right, so here's the photoelectric effect. It says right here, when light hits a metallic surface, so think about solar panels, it produces, I can't draw very well today, it produces an electric current, right? So and that will be letter D. Okay. All right. So my suggestion to you from your, I'm going to stop recording now.